Hello everyone! The company Burroughs sent me for a review their Voron Zero 3D printer kit. Voron Zero is a do-it-yourself printer developed by Voron Design. So in this video I will unbox the kit and I will build and test the printer. If you hear first time about Voron Design, go to their website vorondesign.com. They are designing great do-it-yourself 3D printers, and I have already built two of them. The flagship Voron 2, which is high-performance Core XY 3D printer, and Voron Switchwire, which is the most easy to work with printer I had. Voron Zero is the latest printer from Voron, and it is very small. The hotbed is just 12 by 12 centimeters. To get an idea how small it is, here is what it should look like next to my other Vorons. Although small, it offers nice features like choice between direct or Bowden setup and range of supported hot ends. E3D V6, Dragon or Mosquito. Finally, it's fully enclosed, which will allow me to print my favorite filament, ABS. So you may wonder why building a printer with such small printing volume. Well, for my printing usage, the advantages are clear. It will be a great second printer for smaller parts. It is Core XY machine, so it means fast speed. And the design is kind of simplified because you don't need anymore a probe and auto-bed leveling for hotbed such small. It should be also very energy efficient, and I won't need anymore to power up this monster to print small parts like this one. When building a 3D printer yourself, the starting point is to get the hardware. Voron supplies a configurator and an Excel sourcing guide with all parts. Normally, you have to purchase them from many different suppliers, mostly on AliExpress. That is what I did for my other Voron printers, and it was a nightmare. I generated tens of orders, and it took me more than 2 months per printer to get everything. Some parts arrived for 3 weeks, others for 2 months. Some orders never arrived, and though the dispute system on AliExpress is great to get a refund, it was another month lost. The main benefit of buying a kit is that you get all parts at once. So it's a big time saver, it's one-stop shopping. It arrives quickly. This one was sent by DHL and I've got it for a week. Now buying a kit means also you don't have control on each of the components of the kit. The Burroughs one, however, seems packaged with quality key components like gates belts, genuine Highwind rails and LDO motors. Let's unbox it. The kit came in a compact box. The weight is 6.5 kilograms. It is tight fit inside and everything is very well packaged. The first bag contains all cables, power and control connectors. Then there is a box with the hotbed, 6mm thick aluminum plate that is black anodized, silicone heater 60 watt at 24 volts, magnetic sticker and double-sided PE spring steel sheet. In the same box is the control board, an SKR E3 Mini version 2, the same that powers my Voron switch wire. These are pre-cut and taped 1515 black aluminum profiles to assemble the frame. And here is the motor kit from LDO. Let's look inside. LDO is known for their quality stepper motors. There are two big 48mm NEMA 14 motors for the XY movement. They are high temperature, rated up to 180 degrees Celsius. The extruder motor is 36mm round pancake stepper, also high temperature, up to 180 degrees. Finally, for the Z, there is an NEMA 17 motor with integrated lead screw, supplied with normal nut and an anti-backlash nut. Next box contains 2.5mm thick acrylic sheets, transparent and black, for the enclosure. Here is the PCU. It is a mean-well power supply with 150 watts of power at 24 volts. It could be used with 220 volts and 110 volts mains voltage and covers all world standards. There is also a bag with all needed screws, nuts and heated threaded inserts for the plastic parts. The last box contains everything else: plastic cable chain, Teflon tubes, double-side adhesive for the panels, the hot end. I took the Dragon Standard Flow one, thermal fuse, thermistor, heater, springs, and many other small parts I will discover during the build. For powering the Raspberry Pi, there is a converter 24 to 5 volts. Three 30mm fans are supplied, 2 blowers for the part cooling, and 1 fan for the hot end. The 6mm belt is a genuine Gates. The C14 power inlet with the fuse and the Raspberry Pi 3B Plus, which is more than enough to run Octoprint with Clipper. In the kit, there is also a 32 MB memory card for the Raspberry Pi. The dual drive gears for the direct extruder, set of bearings, and here are the MGN7H linear rails from Highwind. They seem genuine and move smooth. Have to be cleaned and greased before installation. The last key component is the 1.3-inch display.
Overall, it seems very nice kit. There is a link in the description to the product page. Of course, the kit doesn't include any printed parts. You will have to print them yourself using the STL files provided by Voron, or if you don't have a printer, you can order the parts from the Voron community or on AliExpress. I have already printed everything and I'm ready to start the assembly. Just before that, I cleaned and greased the linear rails. They come with some conservation liquid that has to be removed. If they were big size like MGN12, I would have cleaned the rail and the carriage separately. But here I didn't dare to remove the carriage, so I just washed the rails with isopropyl alcohol. When they are clean, the carriage should slide very easy. High wind carriages have holes for oiling, which makes the greasing easy. Next, I arranged all the screws and nuts on my desk. The good thing is, those that are not obvious are labeled, but the letters are so small that soon I needed my magnifying glass. Voron releases assembly manuals for all of their printers. They are very clear and detailed. In the beginning, there are few pages that help to identify the various mechanical components of the frame. Then you are guided step by step. This is the only resource you'll need to assemble the printer. It is almost like an IKEA manual. What is different from IKEA is that there are always some extra nuts and screws. Nice. I shot a time lapse of the assembly. I hope it gives nice overview. Let's see it. I'll make some notes on the most important stages. The process may seem fast on the time-lapse, but it is not. There are many measurements and little adjustments to perform while assembling the frame. For me, the frame was the slowest stage of the assembly. Throughout the build, there are many heated plastic inserts to install. Less than in other Voron printers though. It is fast learning, but if you don't have experience, you may destroy some parts. In the assembly manual there is a link to a video tutorial for plastic inserts you may want to check. Here I'm assembling the A and B drives. They move the belts and the print head on X and Y. Those are very solid devices and each drive is equipped with a belt tensioner. Initially, I thought it may be a good idea to print some 90 degrees corners to reinforce the frame. But it is not needed. When all the components are in place, the frame is rock solid. It is really very well designed. It's now day and a half I'm assembling this. I spent maybe 16 hours on it and I'm still just here on the mechanics. I haven't yet touched to the wires, the afterburner, the electronics, nothing. Honestly, I find this build more challenging than the Voron 2.4. For the switch wires I spent day and a half. The 2.4 was about 3 days. And this one will take, I think, more time. Everything is so tiny, it's like building a Swiss watch. It takes time to adjust all the movements, it requires few tries, so everything moves smooth. I forgot some nuts to insert in the profiles, so I have to go back. So my advice is don't assume anything, read carefully through the manual, don't look just at the pictures, read the texts, and maybe you'll be faster than me. But now my weekend is over, so I'll have to leave this guy for the next one. It didn't happen like that. Next morning, 5 AM, I was installing the belt. Maniac, she called me. Anyway, the next stages were quite easy actually. The correct XY arrangement requires equal belt tension. The easy way to do it is to use belts with the same length. Then the fine adjustment is done with the belt tensioners. Installing the belts was pretty fast, it took me less than 30 minutes. Preparing the hotbed is also easy. The aluminum plate in the kit is 6 mm thick and black anodized. Voron prescribes MIC6 fine milled and casted aluminum for the plate of their printers. There is no way for me to say whether this one is MIC6 or not, most probably it's not, but I also think it doesn't matter for a plate this small. The silicone heater looks good quality with PTFE isolation on thermistor wires. It has the same sticker like Kinuvo heaters, and I don't expect any surprises here. After installing the heater, I've put some weight on it for an hour in order to improve the adhesion. As additional safety measure, Voron advises to install a thermal fuse for 125 degrees Celsius. This fuse will disconnect the bed in case the integrated MOSFET on the control board fails in closed position and if the software thermal runaway protection is off. The build plate is taped already to screw the fuse, and all you need to do is to connect it in series to the heater wires. The PE steel spring sheet and the magnetic sticker seem like an Energetics product. It's quality. I use the same Energetics products on my Voron 2.4 and CL10 printers, and I'm very happy with their performance for PLA, PETG, ABS and even the Polymax polycarbonate. Mounting the hot bed on the printer is straightforward. It lays down on 3 springs for manual bed leveling. Before entering the energy chain, the cables are routed and fixed with pigtails in a dedicated pass-through. The end stops on Voron Zero are mechanical limit switches. They come pre-wired with DuPont connectors and soldered on the normally closed contact. I cut the wires to the length I needed and replaced the DuPont with JST connectors, also supplied in the kit. You can install direct or Bowden printhead on Voron Zero. Myself, I will use the direct one. It is called Afterburner Mini and it is the smallest and the lightest printhead I ever worked with. It supports 3 types of hot ends: E3D V6, Dragon and Mosquito. It is tight fit inside and inserting the fans requires some force, but the design is well thought and at the end everything fits perfect. This is the only part I printed with Polymax PC instead of ABS. This polycarbonate is easy to print and has better thermal and mechanical strength than an ABS. Based on my experience with the Afterburner printhead on my other printers, I believe polycarbonate is better choice for the printhead. The power supply, the Raspberry Pi and the control board are really easy to mount because they are just stuck with VHB double-sided tape. The wiring is quite simple and well documented in the manual. There is enough space for everything. I am not very proud how my wiring works, but I wanted to keep the original Stepa cables. If you cut these cables to length, it should look much better. Here is the Voron Zero display. This hardware is developed by Voron. It connects directly to a Raspberry Pi running Clipper and not to the control board. It has to be flushed from Clipper in the same way like the control board. Maybe you saw that the chain here doesn't stay straight like it should be. There's nothing wrong with the kit, you can do it straight if you want. It's just my preference. I did it this way by swapping the two end elements because I prefer to have larger bending radius and go easy on the cables. All Voron printers run on Clipper, but in this video I won't speak about installing Coq2Print or Clipper because those are quite standard procedures. There is a lot of information, tutorials, and it's quite easy. What I can say to those that are reluctant to switch from Marlin to Clipper is that Clipper is really very user-friendly platform, and you don't need to recompile your firmware every time you change something on your printer. There is a single configuration file you can edit and upload over the air and have the new settings applied, so it's really very easy afterwards. Voron provides a Clipper configuration file for Voron Zero. You will find it in the Voron Zero repository on GitHub under firmware. So I used this configuration file without any modifications with the Blue Rose kit. All my printers are running on Clipper, including my old CR10. Yeah, I know, it doesn't look like a CR10, but it's a topic for another video. For now, let's go back to our build and install the enclosure. The acrylic panels are mounted with printed elements. The process is easy and fast, somewhat annoying because there are a lot of corners to prepare with VHB tape. The panels are precisely cut and very good quality. The black ones are glossy and reflective on one side and matte on the other. The door is on printed hinges and with magnetic printed handle. The top hat is also easy to assemble if you can print it in one piece. If you print the parts on a small printer, you can print it in 4 pieces, but the assembly and the fit are more difficult. You can permanently fix the top hat with screws in the 4 corners. However, it is pretty stable without the screws. It is easy to remove it when printing PLA and to install it back when printing ABS. The printer looks gorgeous. The only thing that kills my total satisfaction is this drop of instant glue just in front of the print head. After a manual bed leveling with piece of paper, I did several prints to tune the printer up. Here you see my first print, a PLA benching. I was expecting that three 30mm fans will make a lot of noise, but they are surprisingly silent. Here is the noise captured by the camera, but actually I hear much less noise than this. This first print came with some artifacts, overheating in the bottom layers and stringing due to my new profile, but also with some irregular layers. Let's see all the tests. Layer height is 0.2mm on all prints. Here I tested the cooling at high speed. It struggles with layers this fast. Of course, for bigger parts it will be better. But the main fight was with the irregular layers. The system is small and very rigid, and every imperfection like a loosened screw or bad tension on the belts is visible on the print. I had to play a lot with the belts to find the right tension. This printer doesn't like over-tightened belts, and the equal tension is crucial. These three ABS cubes illustrate best my failure and success while tuning the printer. Now when it's set, it prints with more or less constant quality, and the first functional ABS parts are similar to those printed on my Voron 2.4. Now I reprint and I will replace the parts of the drives, because before I printed them at layer too high at 0.4 and they look kind of ugly. Like every enclosed Voron printer, the Zero is a beast when printing ABS. So far, I didn't have any failed ABS prints because of wrapping or anything else. I measured the temperature in the enclosure with the hot end thermistor and hot bed at 95 degrees Celsius. It reaches 46 degrees in 20 minutes, which is very fine for printing ABS. Let's wrap up both for the printer and the Burroughs kit. This is a small, reliable and robust 3D printer, a rigid system that will give you constant printing quality after some tuning. For me, it's also a design object. I absolutely like it on my desk. Is it for you though? If you like
to tinker and build your own stuff, go for it. It will give you a challenge and bring you joy and happiness. On the other hand, if assembling and working with an Ender 3 is tough, absolutely avoid this one. What I don't like in my current setup with direct print head is that changing the filament on the fly is very inconvenient, almost impossible, but it's the same with my Voron 2.4. So if you are into these 2 or 3 colors prints where you change the filament on different layers, you may consider to switch to a Bowden set. So far I made just mechanical adjustments on the printer, but there are many other options to fine-tune the performance. I didn't change anything in the configuration file besides the rotation direction of the extruder motor and of course PID tuning for the heaters. But if I go fast and furious with this, I should look at the motor currents and also set pressure advance, which is similar to linear advance in Marlin. There is also an advanced tuning to avoid ghosting using an input shaper. It's basically an accelerometer to measure resonance frequencies and speeds and then skip them. But I'm, let's say, less interested in applying electronic solutions before going to the limits of the mechanics. And I've got some ideas already. Now I'm printing the A and B drives, those that remove the X and Y belts and the print head. And here I will print one of the elements from TPU. I would like to see first if it will dump better vibrations, and second if it can help to make the system less rigid by creating kind of dynamic tension on the belts. It's something I did with some success on my Switchwire already. Well, if I have success, I would make a video about it. If you don't hear from me on this topic, it's because it was an epic failure, most probably. So now for the Burroughs kit, honestly I think it's a great kit. The linear rails are very good. I saw on the forums some people complaining about wobble and play here on the direct drive. With these rails there's no play whatsoever. I mean, there's no need to apply any mods to get it stable. Same for the bed, it's very solid. And I also like that the kit is complete. I saw there are some kits without the display, which is, by the way, an optional equipment, or without the panels. Here you have everything, and the key components are good ones. So this was my review for the Burroughs kit and building Voron Zero with it. Check the description for more information. If I forgot to say something, it will be there. And see you for my next project. Bye bye.